Hello again. This is the NASA Big Idea Challenge team with our weekly update for the mechatronics. This week, currently, we're still building the proof of concept model. Asher spent a long time and one long night building a scale CAD model, which you'll see later. And then we have to move our test bed because we ran into a health hazard with the materials that we're working with. This week, we also completed the microcontroller build that AJ will talk about. We're finally done 3D printing our parts after some headaches. And our previous meeting this week, we went through our very extensive backlog and made sure everybody's up to date on the tasks that we need to complete.
All right, so our test bed has been filled with material to simulate the regolith on the moon. This is courtesy of Simon. It was one of Kathy's contacts. They donated this material to us. So the thing is level on the floor, but we've created a slope. It ranges from 5 to 40 degrees on the side there. Different materials in this test bed include the coarse granite, which you can kind of see towards the left-hand corner, and then the sand creates the slope. As Kaiden was saying, we do have a third material. It's a crushed granite. It's a very, very fine powder, but due to some OSHA regulations, we cannot dump it into our test bed while the test bed is inside. We have found a location, talking with Dr. Lally, to move it outside. That will be done probably after this semester. So right now we're going to test it separately. We'll test on the sand, and then if we want to test on the very fine dust, we'll take the container with the dust outside itself to test.
So this week, as Kaiden said, we finished 3D printing and finally assembling our shaft pieces. And we started the design of our chassis. It's on the bottom here. We have a couple more pieces to finish and fix up this one. And then we'll be laser cutting them, hopefully with Dr. Landy's tools and out of 1/4-inch plywood. And next step, it would be to assemble all of that.
This week we finished building the microcontroller circuit to control the 4 motors we have that are all running off a 12-volt LiPo battery. Next steps are to attach it to the prototype once that's ready, and then to add sensors like encoders for feedback.
One of the things we have to have for our submission for the NASA project is a full model of kind of example of what we're thinking. This model isn't a final design, and it isn't a something we might even build. It is something of, here's the intent of the project. And it's 26 inches from flat side to flat side on hexagon pattern. It's got 82 legs. So it's about 700 square inches and 1 leg every 8 square inches ish. It's got 4 of the motors that we selected, kind of driving each driving rod for the whole drive system, and is built out of different materials. And then one thing we're still working on is the magnetic test bed. Maxwell's equation that describes magnetic force is a really complicated partial diff problem. And rather than solving that and learning partial diff, we can experimentally find it. And the idea is take a box, have it supported by 4 legs, add force and map the added force versus the compressed distance of the legs. And so as it moves, it's going to result in more force because the maps can be close together, and we can kind of get a good idea of what we can expect out of the response of a fully magnetic driven system.
So project next steps, like we said earlier, we're going to build the concept and hopefully start testing it here. As Asher was talking about earlier, we will build and test a magnetic drive instead of trying to solve it theoretically, because it is a mess of mathematics stuff. Like I said, test the concept. We need to start writing our budget. This budget is actually for the proposal, which will be the following 2 semesters, run similarly to senior design. And then our NASA proposal document is also due as of today in 61 days, January 18th. So we're starting to compile our information for that as well. Thank you. And if you have any questions, let us know.